Okay, you guys, we are having a few technical difficulties here, so we're gonna take a moment before we get started. There we go. All right, so let's go over a few of these homework questions and see what we can do. All righty, so this one. Box slides down a 31-degree ramp. You're given acceleration and you're asked to find the coefficient of kinetic friction. Now, if you look at this quickly, the first thing you may realize is that we don't have mass, and that's a new one. But don't despair. Don't figure that it is an impossible task because you don't have mass. That is not true. It is not true at all. We do this in AP Physics quite often, where we don't have any numbers and we have to figure stuff out. Ooh, another uncalibrated board. Okay. Well, we're going to just do the best we can here. All right. Let's maybe another marker will be a little bit more calibrated. You never know. There we go. All right. So we know the angle, right? Let's put in our free body diagram anyway. So we know that this one is mg, yes? And normal force is here. It might be a little off kilter. Friction must be going up the ramp. Oh, that looks like an arrow, doesn't it? All right, friction's got to be going up the ramp or they wouldn't be mentioning it. And then we've got this piece and this piece. This is our gravity, right? Broken up. We've got mg sine of theta here, and we have mg cosine theta over here. Okay, hopefully now none of this is news, right? We should know this by now. And it's saying, all right, we're accelerating this way down the hill, right? So let's consider, what do we know? We know that normal force is the same as mg cosine of theta. Yes, right? These two, they're equal to each other. We know that. We also know that if the forces were balanced, this one would equal that, but it's not balanced. We're accelerating down the hill. So we're using our bigger minus smaller thing, right? MA equals the bigger one, mg sine theta, minus the force of friction. Okay, now let's think about this. We don't know mass, we know acceleration, we know g, we know theta. So this is really the only sticking point right there. But you know what? I know something else. I know something about friction, right? Friction has the coefficient of friction. Yes? Mu Fn equals the force. Oops. I hate when I can't see what I'm doing. This is very disconcerting to write and have it actually not be in the right spot. Okay. Mu Fn equals force friction. Let's substitute that in. What's Fn equal to? Oh yeah, it's equal to that. A lot of substituting, but look what happened. Bye-bye mass, you're gone. We have it in every single thing, so you can actually solve this without the mass. Okay, now let's consider what we know. We know acceleration. We know g. We know theta. We're looking for mu. Okay, I didn't mean to circle in the middle. We know g, and again, we know theta. You now have the capability to solve for mu. It's not impossible to do. All right, so have a little faith, set things up, substitute, substitute, substitute until you get to that one. All right, next. Girl coasting downhill, given speed, and you're given coefficient of friction, and you're given, oh, notice you're not given mass, you're given actually mg, you're given the force of gravity. So I bet you I get a few folks that make that mistake and they try to convert that when they don't have to. Right, so what am I talking about? I'm talking about right there. You notice that that is in newtons already. That's Fg, so you don't have to do any math there with that to get it to Fg. That's the good thing. All right, so again, we're going down the hill, right? And we're accelerating down the hill. That's a key. So let's think, what do we have? We have Fg Dang, this is, all right, this is just a mess. Definitely need to make sure I calibrate these in the future before I work with them. There's FG. There's my force of friction. All right, mg cosine theta, mg sine theta, and then this one is our normal force. Okay, what do we know? We also know his speed. And we want to know how far she travels. That tells me I'm going to need a VT graph, and it's going to look like that. Hopefully it starts at the origin for you. All right, we want to know how far she goes. We want to know the area under the curve. So we're going to need TF, and we're going to need VF for that. So that's kind of where I'm heading with this one. Using this stuff over here, what I'm going to be looking at, I'm going to try to find the acceleration. That's what I'm going for. Once I know the acceleration, it goes there. It's the slope of the line. And then you should be able to find the VF and the TF and use the area under the curve. Right? You'll have a number here, so you'll be able to substitute one into the other. We've done a million of these. We've done a million of these. I'm hopeful you will see the pattern. Okay, so again, bigger minus smaller equals net. Bigger minus the smaller. You're going to use the coefficient of friction to find your friction. You should have all of these. You should be able to find A, or A, depending on where I decide to touch the board. Once you have A, you've got your slope. Once you've got your slope, you've got this. You know, whatever your number is here times TF equals VF, right? And then you can put it in there and find how far it goes. All right. Many, many steps, but the bottom line is you want to find your acceleration using your force diagram and then put it in over here. All right, now that may not seem like a total step-by-step method, but let's face it, you guys are at the end of this unit. So all of those things should be familiar to you. And then I will be happy to answer individual questions if you are still struggling with the math. All right, everybody, until next time, talk to you later.